Heat has always been a mystery. Antoine Lavoisier theorized that heat was a substance with mass. That meant that heat transfer involved the transfer of an actual substance between bodies. Unfortunately, Lavoisier's theory was not supported by experimental observation, so a better description of heat was needed. Heat has always been confused with temperature, but the reason is that heat and temperature are related. Temperature is a quantitative measure of hotness or coldness. Solids, liquids, and gases are made up of atoms and molecules. When these atoms and molecules are moving slowly, then the temperature of that substance would be low. The faster the atoms and molecules move, the higher the temperature. Heat is the total energy of these atoms and molecules as they move. This figure shows how the speed of the atoms and molecules is related to the temperature of the substance. The total energy of the atoms and molecules shown in the figure on screen is what we call heat. Here are some interesting facts and properties of heat energy. The figure here illustrates the direction of heat transfer between two substances. Heat transfer is when heat energy flows from the object of higher temperature to an object with a lower temperature. It will never do the reverse. Heat energy can be transferred by the following methods: conduction, convection, and radiation. Let's first look at the process of heat transfer by conduction. Consider the following situation, which you may have experienced. You have a cup of very hot coffee, and you put sugar into the coffee and use a spoon to stir the coffee. You accidentally left the spoon in the coffee when you left it on your table. Minutes later, you grab the spoon from the coffee and notice the spoon is now hot. The spoon, which was initially cold, is now nearly as hot as the coffee. This situation is an illustration of conduction. The molecules of the spoon immersed in the coffee were forced to move faster. These faster-moving molecules bump into adjacent, slower-moving molecules and cause them to move faster, etc. After some time, all of the spoon molecules will be moving faster. Conduction is a process of heat transfer where the faster-moving molecules impart their energy to slower-moving molecules until the entire substance is moving with a faster speed. The figure you're looking at on screen illustrates conduction. The second heat transfer method is called convection. Ever hear of the statement that warm air rises? This statement describes convection. Convection, illustrated in the figure here, is the method of heat transfer that involves large masses of a substance circulating because of the temperature differences within that substance. As the warmer mass rises, the cooler mass moves down, and in the process, heat is transferred to the cooler mass, which causes it to move up. The third heat transfer mechanism is called radiation. Radiation is the method that allows us to get heat from the sun. Through radiation, the sun is able to transfer energy to the Earth even through the vacuum of space. Also, every object gives off radiation. You give off radiation, your dog gives off radiation, and even an ice cube gives off radiation. If you put a piece of metal into a fire and take it out after a few minutes, the piece of metal will glow. This is an example of radiation. The sun sends us radiation in a short wave, and the Earth emits the radiation in a long wave. Another interesting fact about heat is that different substances absorb as well as give off heat in varying amounts. For example, consider boiling water. Before the water boils, you can still put your hand in the water, but you can't touch the pot. What does this mean? Water takes longer to absorb heat than the metal pot containing the water. This is because the water and the pot each have a different specific heat capacity, which is the amount of heat needed to raise the temperature of a specific mass by a specific amount. Metals have a low specific heat capacity, and liquids like water have a higher specific heat capacity. This means that metals will heat up and cool down quicker than water. So, when the temperature of a substance changes, we can calculate the amount of heat transferred if we know the specific heat capacity and the mass of the substance. The formula for heat is then heat equals mc delta T, where delta T equals T final minus T initial. In this equation, m is the mass of the substance and c is the specific heat capacity of the substance. The table here is a list of specific heats for a few substances. The unit for specific heat capacity is joule per kilogram per degree Celsius. A joule is the standard unit for any type of energy. As an example, let's calculate how much heat is needed to boil 0.100 kilograms of water if the water was initially at 20 degrees Celsius. The calculation would be heat equals mc delta T equals 0.100 kilograms times 4,186 times J over kgc times 100 minus 20 degrees Celsius equals 33,488 joules. Note that the amount of heat can be positive or negative. If the temperature change is positive, the heat is positive, so the object gained energy. If the temperature change is negative, the object lost heat. Heat and temperature are often confused with each other. While temperature is related to the speeds of the atoms and molecules in a substance, heat is the total energy of these atoms and molecules. This means that objects with a higher temperature have more heat energy than objects with a lower temperature. Heat can be transferred by conduction, convection, and radiation. Conduction is a process of heat transfer where the faster-moving molecules impart their energy to slower-moving molecules until the entire substance is moving with a faster speed. Convection is the method of heat transfer that involves large masses of a substance circulating because of the temperature differences within that substance. And radiation is the method that allows us to get heat from the sun. Heat transfer occurs in one direction, always from the hotter object to the colder object. To calculate this heat, we need to know the specific heat capacity, or the amount of heat needed to raise the temperature of a specific mass by a specific amount of the substance. Specific heat capacity of a substance is proportional to how much heat is needed to raise the temperature of that substance, as outlined in this image here. High specific heat capacity substances, like water, require more heat to raise their temperatures, while low specific heat capacity substances, like aluminum and copper, require little heat to change their temperatures.